Okay, yesterday we looked at alkanes and isomers, naming them, that sort of thing. It's chemistry, so we actually want to know more than just the facts about them. We need to know about the properties and the reactions. And I'm just going to look at a couple of those to start with. So what I've got here is cyclohexane, which is C6H12. It's cyclo, that's why it's the CnH2n, not 2n plus 2. In here I've just got tap water. I probably should have used distilled water, but tap water will do the job. And in here I've got a chemical called bromine water. All that means is, as the name suggests, it's bromine dissolved in water. Bromine doesn't dissolve very well because it's non-polar, so it's actually been made with a bit of, I believe, bromate, BrO3 negative, so that it will dissolve. So the alkanes don't have particularly exciting reactions. In fact, you're going to find this is quite short and sweet. But we do need to be able to justify what we see. So what I've got here is the cyclohexane. And first of all, we're going to see if it will dissolve in water. So things that do dissolve in water appear to just be one substance. If they don't, then they go cloudy, so like a precipitate, so that's a suspension, or they sit on top. So what I'm going to do is I'm actually going to put it in and then shake it and see what happens. And we can see quite easily there that it's gone all bubbly down here, where some air from me shaking it has been caught, and we've got a small layer on top and a big layer on the bottom. Remember that the water was that size to start with, so it's showing that it's not dissolving at all in water. The word we use for this is immiscible. So when a liquid won't dissolve in water, we call it immiscible. IMMISCIBLE. So why would that be? Well, if we go back to one of our previous topics, this is just made up of carbon and hydrogen. And all of those bonds are non-polar or pure covalent. This means that the compound itself must also be non-polar. And it also has no ability to make hydrogen bonds, something you'll learn about in level 3. So therefore it has no ability to dissolve even a little bit in water. The temporary dipoles that it could make are so irregular, they're so infrequent, that it's got no ability to dissolve at all. All right? And this is why we see petrol floats on top of water as well, because it's made up of hydrocarbons. See, alkanes will not dissolve in water. That's what that's showing. I hope that actually can be seen as the two layers on the video there. Another thing we can look at with alkanes is what happens when we put them with bromine water. Now, bromine as an atom is actually, it has a very good ability to bond with things like carbon. So it should be able to displace a hydrogen and put a bromine in there, what we call a substitution reaction. So if the bromine if there's enough activation energy and so on, we would expect that the bromine, being what we call a highly electronegative element, is able to be attracted to the nucleus of the carbon, pushing off, substituting out a hydrogen. So we'll see what happens with this and see if that is exactly what happens or not. Now remember, this is bromine water, so the bottom layer is going to be the water part, okay? And if we shake it up a bit, we can see that the bromine has been pulled into the top layer because it dissolves better in a non-polar solvent, but it's not actually changing colour, all right? Which means it's not doing the reaction that I just described. There's nothing happening. Now, if I give that enough natural light, so the ultraviolet wavelength of light, if I give it enough natural light, eventually it'll react. But it doesn't happen in front of our eyes. So that's a really good test for alkanes, because alkenes don't do this, as we'll see in a future lesson. Alkenes have a different observation. So the colour has been pulled out of the aqueous layer because it dissolves better in the cyclohexane, but it's not actually reacting. I'd need ultraviolet light, and if it was reacting, if it's replacing a hydrogen, then that means that it would be making HBr. And HBr is an acidic gas, just like HCl is an acidic gas. So I've got a test here. Let's see if it actually is reacting. I've got litmus paper. I'm going to make it damp. So blue litmus paper, sorry, I should have been specific there. If this goes red, then it is actually reacting, just not at a rate that we can see. And nothing. Absolutely nothing. So that's sort of a confirmation that no, there's no substitution happening there, or if there is, it's so slow. There's not enough activation energy there, as it were. Now, as I say, if I was to leave it out in the sunlight, then maybe we'd eventually see this orange colour fade a little bit, and my blue litmus would eventually change. But it does take a very, very long time. Whoops, I'll have to deal with that later. Those are the two key things. So, doesn't dissolve in water because it's non-polar, doesn't react with bromine water very quickly, and if it was to react, it would require ultraviolet light, so the ultraviolet wavelength of natural light, and it would still take a very long time. And by a very long time, I mean for that, it would take 10 minutes for us to be able to observe anything changing in that bright orange layer. It does, however, dissolve bromine very well, because bromine is non-polar, and so is the alkane.